Our universe is 13.8 billion years old. All of the universe that is observable to us hosts hundreds of billions of galaxies and more than a trillion stars, home to many more spectacles and intergalactic events that leave us with plenty of curiosity and many more questions. How big is the universe? Why does it have so many stars and galaxies? How do stars and galaxies form? What will be the future of our universe? Let's begin at the very beginning. How did it all start? Our universe began with an explosion of space itself, the Big Bang. The famous galactic event explains how all matter in existence formed, from a tiny singularity point to the massive clusters of stars and galaxies. During the very early stages of the universe, the laws of physics may not be like what we know today. Back then, the universe was extremely hot and saw the emergence of four fundamental forces before anything else. About 300,000 years after the Big Bang, the first subatomic particles of hydrogen and helium started to form. Between 150 million to a billion years after the Big Bang, these particles began to collect into higher density regions of space to create clouds of nebulae. Finally, the universe slowly saw these clouds form into stars and galaxies. To answer the questions, how were these stars and galaxies formed in the first place, we need to know what stars and galaxies are. Galaxies are a collection of stars, dust, gas, and dark matter, all held together by gravity. The first observation of galaxies date back to 300 BCE when Greek philosophers believed that our galaxy contains numerous distant stars. The observation continued and saw much progress during the Golden Islamic Age. Still, it wasn't until Galileo used a telescope to prove these distant stars in the sky. The latest observations from James Webb Space Telescope suggest that the first galaxies formed 200 million years after the Big Bang. Astronomers and physicists are still determining how galaxies formed in the first place. It is still an open-ended question, but many theories have been proposed on its formation. These theories are mainly divided into two categories of top-down and bottom-up theories. Top-down theory proposes that vast areas of dark matter and gas clouds in the early universe bundled together before breaking down into countless smaller and denser clouds that collapsed further and became the early galaxies. This theory is not widely accepted anymore, which moves us to our other theory. Bottom-up theory proposes that dark matter particles slower than the speed of light, known as cold dark matter, interacted with gas clouds in space to form smaller masses first. Then gravitational force came in the act of creating larger masses, which further merged with other larger masses and became the first galaxies. This is a relatively recent theory that is gaining wider acceptance compared to the other theory. Galaxies are still forming. Every single one of them has its unique characteristics. They are mainly classified into three types because of their shapes. Spiral galaxies have arms spiraling outwards from the center. They make up the most galaxies in our observable universe and consistently form newer stars. Elliptical galaxies don't have any spiral arms. Their appearance is more egg-shaped, and for them the star-forming process more or less has ended. Irregular galaxies are neither round nor spiral-shaped. They are known as irregular because of their lack of definite shape. They only make up 3% of the entire galaxies in our observable universe. Our Milky Way galaxy is a spiral galaxy that spans 100,000 light-years. Home to hundreds of billions of stars, is also home to a supermassive black hole at its center. Nearly all galaxies hosts at least one supermassive black hole. Galaxies can also collide with other galaxies. When two galaxies collide, the star system within them largely remains safe because of the enormous distance between these systems. The collision brings about massive amounts of dust and gas clouds that become the catalyst for millions of newer stars. Sometimes the colliding galaxies don't have enough momentum to pass through each other, so they end up merging together. Simply put, the larger galaxies eat up the smaller ones. Millions or even billions of years may have to give before these two galaxies can merge completely. Our own Milky Way galaxy has swallowed many smaller galaxies during its lifetime. The Milky Way galaxy is set to collide with our neighboring Andromeda galaxy in about 5 billion years. It is thought that the largest galaxies can be 10 times as big as the Milky Way galaxy and may be home to more than 1 trillion stars. Stars are the atom of the universe. Out of all the stars in our universe, only 4,000 of them are visible to the naked eye. Most stars in our universe are 1 billion to 10 billion years old. The very first of them formed when the universe was about 100 million years old. But how did these enormous spheres of luminosity came into being? The process of star formation is an intricate one. For the purpose of this video, we will focus on the formation of individual stars and not a system of stars that form in clusters. A star's journey begins when a giant nebula cloud made entirely of hydrogen and helium collapses inward under its gravity. The collapse causes the cloud to shrink and spin more and more quickly, making the outermost part a disc-like shape, while the center becomes a spherical clump. This clump becomes hotter and denser over time and forms a ball-shaped core known as protostar. The protostar then draws in gas from the surrounding and becomes even hotter. When the temperature of protostar reaches 1 million degrees, atomic nuclei inside it starts to fuse. This counteracts the gravitational collapse and tries to stop the further collapse. When enough mass has collapsed into this protostar, two massive jets of gas erupt and blast away the remaining gases. When the temperature of a protostar reaches 10 million degrees, the hydrogen begins to fuse. This is known as nuclear fusion. It converts a small amount of mass into massive amounts of energy, and just like that, a star is born. Just like galaxies, stars come in wide ranges of shapes, sizes, and masses. The critical differentiator is its mass. A star will spend about 90% of its life fusing hydrogen into helium. Typically, stars with more mass light brighter, burn quicker, and die faster. Burn quicker takes roughly 50 million years to form. At the end of a star's life, it either becomes a dwarf, neutron star, supernova, or a black hole. In case of a supernova, a star dies in a big explosion and bursts all its enriched material into space. These materials are then recycled into newer stars. The process of star formation will end once all available hydrogen in the universe turns into heavier elements. Edwin Hubble discovered that the galaxies around the Milky Way are moving away from us at rapid speeds. Years later, astronomers found it to be accurate and determined that the universe is not only expanding but also accelerating. The name for the unknown force driving this expansion is dark energy, and it remains one of the greatest mysteries in science. The intricacy of the expansion is such that if the rate of expansion had been slower or faster, even to 1/1,000,000th of a second, the universe wouldn't have existed. The universe today looks the same as it did 12.8 billion years ago, and it will continue to be very similar for many billions of years into the future. Stars and galaxies are incredibly important to us. By observing the formation and evolution of stars and galaxies, we can not only piece together how the universe has changed over time, but they may also tell us how the universe will change. We know at some point in time the stars will no longer be born, and the expansion of the universe will mean that eventually all galaxies will be carried away from us. The universe will become larger, colder, and darker. All the structures will eventually decompose into subatomic particles. At some point, the expansion and acceleration will become so extreme that not only subatomic particles, but the very fabric of space-time will be ripped apart, ultimately leaving nothing or something beyond the constraints of our knowledge. If you would like to see more of this, be sure to check out our previous videos and don't forget to subscribe. Hit the bell icon to stay notified of the upcoming videos. If you have some future video suggestions, comment down below.